Good morning, students. Welcome to the live session. In this live session, I am going to discuss in detail about the concept of electrochemistry. Good morning, Madhu. What is meant by electrochemistry? So, electrochemistry is a branch of chemistry that mainly deals with two important energy conversions. So, especially electrochemistry deals with two important energy conversions. One being the conversion of electrical energy into chemical energy, and the second one is the conversion of chemical energy into electrical energy. So, electrochemistry mainly deals with two important energy conversions. One is the conversion of electrical energy into chemical energy, and the other one is the conversion of chemical energy into electrical energy. So, what is the device used for the conversion of electrical energy into chemical energy? If you are having any idea about the device, you just share your answer. So, what is the device used for the conversion of electrical energy into chemical energy? If you know the answer, you just share your answer through the message. Yes. A device that is used for the conversion of electrical energy into chemical energy is called as an electrolytic cell. On the other hand, a device used for the conversion of chemical energy into electrical energy is called an electrochemical cell. In other words, electrochemical cell is also called as galvanic cell. So, galvanic cell is the device that is used for the conversion of chemical energy into electrical energy. So, before discussing about these two conversions, one should have a basic idea about the few terms like conductors, semiconductors, insulators, electrolytes, non-electrolytes, strong electrolytes, and weak electrolytes. So, especially based on conductance, all the substances can be classified into three types. depending upon the conductance values, all the substances can be classified into three types, namely conductors, semiconductors, insulators. So, based upon the conductance values, all the substances can be classified into three types: conductors, semiconductors, and insulators. So, conductors means they allow maximum amount of electric current to pass through them, and hence those substances are called as conductors. So conductors allow maximum amount of electric current to pass through them. So good examples of electric conductors include metals. All metals are good conductors. We can also consider alloys. Graphite is a good conductor. Even the aqueous solutions of acids, bases, and salts acts as good conductors. So coming to the insulators, they allow a portion of current. So these semiconductors allow a portion of current to pass through them, and hence they are called as semiconductors. Good examples of semiconductor generally include silicon, germanium, and other non-elemental semiconductors are also there. So coming to the insulators, insulators are the substance which do not allow electric current to pass through them are called as insulators. So insulators means they do not allow electric current to pass through them, and hence they are called as insulators. We can also call them as non-conductors. So insulators can also be called as non-conductors. So examples are very important. So best examples for insulators include wood, rubber, paper, glass, all non-metals except graphite. Graphite is a good conductor. So except graphite, all non-metals acts as insulators. Insulators are equally important as conductors. So coming to the concept of conductors, in this topic we are interested to discuss more about the conductors. So let us discuss about the classification of conductors. So these conductors can be classified into two types based upon conducting element. Based on conductive element. So how they conduct electricity, that is nothing but conductive element. So based upon the conductive element, all the conductors can be classified into two types, namely metallic conductors and electrolytic conductors. Electrolytic conductors. So based upon the conductive element, conductors can be classified into two types, metallic conductors and electrolytic conductors. Here in the case of metallic conductors, the conductive element is free electrons. So, free electrons present in the metals and alloys will carry the electric current. Coming to the electrolytic conductors, here the ions are, especially the free ions are responsible for the conduction. So that's why these metallic conductors can also be called as electronic conductors. So what is the other name of metallic conductors? They can be called as electronic conductors, since here the conduction is due to the presence of free electrons. Coming to the electrolytic conductors, here the conductance is due to the presence of free ions, hence they can be called as ionic conductors. So let us differentiate metallic conductors and electrolytic conductors. So in the case of metallic conductors, the conductance is due to the presence of free electrons. Whereas in the case of electrolytic conductors, the conductance is due to the presence of free ions. So good examples are metals like copper, silver, etc. Coming to the electrolytic conductors, good examples are here aqueous solutions of salts or base or acids. So during the conduction, what happens? Here the electrons will flow from, so electrons flow from negative end to positive end. Coming to the electrolytic conductors, here always aqueous, for example, when we consider aqueous NaCl, it undergoes decomposition into Na plus Cl minus. So during the conduction process, what happens? These cations will move towards the cathode and the anions will move towards the anode. So oppositely charged ions will move towards the oppositely charged electrodes. That means during the conduction process here, metallic conductor will not undergo any decomposition. That means it starts conducting without decomposition. Here during the conduction process, in the case of electrolytic conductor, decomposition takes place. And the most important feature of these metallic and electrolytic conductors are, as the temperature increases, here the conduction decreases. Why? As the temperature increases, here the vibrations of atoms increases. So in the case of metallic conductors, as the temperature increases, the conduction decreases. It is mainly due to the fact that due to increase in temperature, the vibrations of atoms increases and hence the conduction decreases. But coming to the electrolytic conductors, as the temperature increases, the conduction increases. That means the conductance increases. Why? It is due to the increase in the mobility of ions. So as the temperature increases, the speed of the ions increases and hence the conductance also increases. So in the case of electrolytic conductors, as the temperature increases, the mobility of ions increases and hence the conductance also increases. These are the important differences between metallic conductors and electrolytic conductors. Let us discuss about the electrolytes. So here what is our point of interest? to discuss in detail about the electrolytes, non-electrolytes, types of electrolytes. So coming to the electrolytes, electrolytes means these electrolytes will undergo decomposition by the passage of electricity through its molten or aqueous solution. So best examples for electrolytes include aqueous solutions of HCl, HNO3, NaOH, NaCl, etc. So here we have to consider acids, bases, even salts always present in the molten state or in aqueous solution. Coming to the non-electrolytes, non-electrolytes means they do not conduct electricity. So non-electrolytes do not conduct electricity. So good examples of non-electrolytes. These non-electrolytes are very important. So coming to the non-electrolytes, they include glucose solution, sugar solution, urea solution, starch solution. So even in the molten state, they do not conduct electricity. Alcohols, oils, even the organic substances like pyridine, these are good examples of non-electrolytes. So what is our point of interest? To discuss about the types of electrolytes. So coming to the types of electrolytes, electrolytes can be classified into two types. So how the electrolytes are classified? They are classified into two types, namely strong electrolytes and weak electrolytes. So depending upon the conductance values, these electrolytes can be classified into two types, strong electrolytes and weak electrolytes. So strong electrolytes undergo complete dissociation. So they undergo complete dissociation. They undergo dissociation up to 99%. But coming to the weak electrolytes, they undergo incomplete dissociation. So here the conductance is due to the presence of free ions. Strong electrolytes undergo complete dissociation and hence they conduct huge amounts of electricity. But coming to the weak electrolytes, they undergo incomplete dissociation. That means they undergo dissociation up to 2%. So the dissociation is always less than 3% in the case of weak electrolytes. So coming to the good examples of strong electrolytes, they include acids like sulfuric acid, HCl, HNO3, bases like NaOH, KOH, salts like NaCl, KCl, etc. Coming to the examples of weak electrolytes, they include acids like carbonic acid, acetic acid, boric acid, phosphoric acid. You try to remember all the examples of weak electrolytes. Coming to the bases, they include ammonium hydroxide, aluminum hydroxide, salts like lead sulfate, barium sulfate, etc. These are the good examples of weak electrolytes. So, depending upon the conductance values, all the electrolytes can be classified into two types: strong electrolytes and weak electrolytes. Here, we are going to discuss about the Arrhenius theory of electrolytic dissociation. So, coming to the Arrhenius theory of electrolytic dissociation. Especially, this is also called as ionic theory, which explains the dissociation of an electrolyte. So, whenever if we consider an electrolyte, it dissociates. Especially, the dissociation takes place only in the aqueous solution. So, it dissociates to give corresponding cations and the anions. And always remember that the total charge of cations is always equal to the total charge of anions. So, whenever an aqueous electrolytic solution is taken, it dissociates to give cations and the anions. Always the total charge on cations is exactly equal to the total charge on anions. And always a dynamic equilibrium, especially a dynamic equilibrium exists between dissociated ions and the undissociated electrolyte. So, always undissociated electrolyte undergoes dissociation, whereas the dissociated ions recombine to give the undissociated electrolyte. So, both forward and backward reactions takes place simultaneously, and hence always a dynamic equilibrium will be maintained between undissociated and dissociated ions. So here we have to discuss about the degree of dissociation. So according to Arrhenius, he defined degree of dissociation, which is also called as degree of ionization. It is highly useful to know the nature of the electrolyte, whether it is strong or weak. He defined degree of dissociation as the ratio between number of molecules dissociated to the total number of molecules taken. So, degree of dissociation can be defined as the ratio between the number of molecules dissociated to the total number of molecules taken. So, especially the degree of dissociation depends on temperature and also on dilution. So, the degree of dissociation values depends upon the two factors. One is temperature and the other one is dilution. So, in particular, this Arrhenius theory is strictly applicable to weak electrolytes. So, Arrhenius theory is strictly applicable to weak electrolytes only. So, later scientists Debye, Huckel-Onsager. So they modified. So Debye Huckel-Onsager modified Arrhenius theory and they applied to strong electrolytes. So Arrhenius theory is only applicable to weak electrolytes. Later, this theory was modified and applied to strong electrolytes by Debye, Huckel and Onsager. So that is about the Arrhenius theory of electrolytic dissociation. Now, one should know what is meant by an electrolysis. This is very important. Electrolysis means it is the process of decomposition of an electrolyte either in the fused state or in the molten state or in an aqueous solution on passing electricity. So it is the process of decomposition of an electrolyte either in the molten state or in the fused state or in aqueous solution by the passage of electricity. So this electrolysis takes place in an electrolytic cell. So let us see good example for electrolysis. That means we are going to discuss about the electrolysis of molten NaCl. So coming to the electrolysis of molten NaCl, electrolysis takes place in an electrolytic solution. That means we have to arrange an electrolytic cell. Especially an electrolytic cell consists of two electrodes an electrolytic solution, and here the two electrodes are connected to the battery. So it is an electrolytic solution, that is molten NaCl. So whenever these two electrodes are connected to the battery, then what happens? Here the first electrode is anode and the second electrode will act as cathode. So on the passage of electric current, this NaCl undergoes decomposition. Okay. So during electrolysis, two types of reactions takes place. One is the decomposition reaction and the second one is the redox reaction. So coming to the decomposition reaction, here NaCl undergoes decomposition and it results in the formation of Na plus and Cl minus ions. So what happens? Always this solution consists of Na plus and Cl minus ions. So anions will move to the anode, cations will move to the cathode. So then what happens? A redox reaction takes place. That means at the anode oxidation takes place and at the cathode reduction takes place. So at the anode, these anions will undergo oxidation with the loss of electrons. Coming to the reaction at the cathode, here these cations gain electrons and thus reduce it to the metal. So whenever an electrolytic cell is constructed and connected to the battery, after some time you will observe the liberation of chlorine gas at the anode and the deposition of sodium metal on the cathode. This is about the electrolysis of molten NaCl. So what are the products formed at anode and at cathode during the electrolysis of molten NaCl? Chlorine gas will be liberated at the anode and sodium metal will be deposited at the cathode. Are you ready to answer few questions? Will you respond? Swati? Voice is audible to you? Okay. During the electrolysis of molten NaOH, what are the products formed at the cathode and at the anode? It is the molten solution. During the electrolysis of molten NaOH solution, what are the products formed at the cathode and at the anode? Yes, very good, Swati. At the cathode, sodium metal will be deposited, and coming to the product at the anode, if the anion contains oxygen as one of the atom, always oxygen gas will be liberated at the anode. So, during the electrolysis of molten potassium sulfate solution, now you just guess what are the products formed at the cathode and at the anode. You can guess the answer and share it. Very good, priceless brains. Okay. At the cathode, potassium metal will be deposited, and here also the anion contains oxygen as one of the atom, and hence oxygen gas will be liberated at the anode. So here, in the case of molten solutions, only one electrolyte will be present. But when we consider aqueous NaCl solution or aqueous copper sulfate solution or aqueous AgNO3 solution, then how to guess the products formed at the cathode and at the anode? So let me explain what happens if aqueous electrolytic solution will be taken. Let us consider aqueous NaCl solution. So in the case of aqueous NaCl solution, here NaCl will be dissolved in water. So here two electrolytes are present. So NaCl dissociates into Na plus Cl minus. And coming to the water, it also dissociates to give He plus and OH minus ions. Here two cations are present. At the same time two anions are present. So whenever if the electrolytic solution contains two cations or two anions, then how to guess the product formed at the cathode and at the anode? Here there is one fundamental principle, that is, so whenever two cations are present, then the cation with, especially the cation with higher reduction potential value gets discharged first at the cathode. It is the fundamental principle. But coming to the anions, the anion with lower reduction potential value gets discharged first at the anode. So these two are the fundamental principles, but here we can guess the products formed at the cathode and at the anode with the help of a simple hint. Okay, so whenever if you consider electrochemical series, or especially in the case of noble metals, you just remember noble metals, they include copper, silver, gold, platinum. So whenever these metals are present in the electrolytic solution, definitely these metals will be discharged first. So if the metal is other than noble metals, then the hydrogen gas will be liberated at the cathode. This is the simple logic. And coming to the anions, always the anion present in the electrolyte will be discharged first. So there is no change with respect to the anions, but coming to the cations, if the metal is other than noble metal, especially in aqueous solutions, hydrogen gas will be liberated at the cathode. If noble metal is present, there will be no change. That metal will be discharged at the cathode. Let us apply this principle to few examples. Now tell me, what are the products formed during the electrolysis of aqueous NaOH solution? This is the first example with respect to aqueous solutions. Students, you just try to share what are the products deposited at the cathode and at the anode. Swati, at once check your answer. Priceless brains, iconic star, you both are also supposed to check your answer once again. Here it is an aqueous solution, that means water is also present. Here the electrolyte is NaOH, so you have to divide the cations and the anions. Here the cation is other than noble metal, then what will be formed at the cathode? If the cation is other than noble metal, then what is the product formed at the cathode? Simple logic. Anyhow, I will explain about the aqueous NaCl. Okay, if it is aqueous NaCl. Here the cation is sodium. It is not the noble metal, and hence what happens? Hydrogen gas will be liberated. And here the anion is chloride, and hence chlorine gas will be liberated at the anode. So if the metal is other than noble metal, definitely in aqueous solutions, hydrogen gas will be liberated at the cathode. And coming to the anion, here it is chloride. So chlorine gas will be liberated at the anode. Boy, just try to share your answer. Very good. Swati. Before sharing the answer, you just check your answer. So here in aqueous NaOH solution, very good iconic star. So here sodium metal is present. That means it is other than noble metal. And hence undoubtedly at the cathode what happens? Hydrogen gas will be liberated. And coming to the product at the anode, here the anion is OH minus. And hence automatically oxygen gas will be liberated at the anode. Very good, Swati. Okay. Next, you try to answer what are the products formed during the electrolysis of aqueous copper sulfate solution. Aqueous copper sulfate solution. Very good, priceless brains. Here the metal is noble metal and hence it will be deposited at the cathode, and here the anion is sulfate, automatically oxygen gas will be liberated. Okay, very good, Swati. And finally you try to answer what are the products formed during the electrolysis of aqueous AgNO3 solution. Very good, iconic star. Here the metal is noble metal. Hence, noble metal will be deposited. And the anion is nitrate. So, automatically oxygen gas will be liberated. Very good, Swati. So, this is all about the products formed at the cathode and at the anode during the electrolysis of either molten or aqueous electrolytic solutions. So mostly you are supposed to answer these products. So you are mostly supposed to answer what are the products formed at the cathode and at the anode during the electrolysis of molten or aqueous electrolytic solutions. On the other hand, sometimes you are supposed to answer questions based upon the flow of electrons and flow of current in the internal circuit or in the external circuit. So let us know how the flow of electrons takes place in the internal circuit and also in the external circuit. So coming to the internal circuit, that means here the flow of electrons takes place from cathode to anode. So in the internal circuit, how the flow of electrons takes place? They takes place from cathode to anode. Why? Here the flow of current especially takes place from, any guess? Flow of current and flow of electrons will be in the opposite direction. Any guess? So flow of current takes place from, very good Swati. So it takes place from anode to cathode. You just remember one logic. So in the internal circuit, always the flow of current takes place from anode to cathode. Whenever you are supposed to answer flow of electrons, you just reverse the direction. That will be cathode to anode. Sometimes you will be asked to identify the flow of electrons in the external circuit. External circuit. Then what you are supposed to do? You just reverse the flow of electrons and flow of current in the external circuit. So you try to guess how the flow of electrons takes place in the external circuit and how the flow of current takes place in the external circuit. You just remember only one point, that is, in the internal circuit the flow of current takes place from anode to cathode. When you are supposed to answer flow of electrons, you just reverse the direction. In the similar way, when you are supposed to answer in external circuit the flow of current, you just reverse the direction. Now you just share the answer. Yes, flow of current takes place from cathode to anode. And what about the flow of electrons in the external circuit? Okay, Nana. What about the flow of electrons in the external circuit? Swati, will you share the answer? Yes, very good. It takes place from anode to cathode. Sometimes you may be supposed to answer how the flow of electrons takes place in the external circuit. Then you have to answer anode to cathode. So this is about the flow of electrons and current in the internal and external circuits. So now it's the time to discuss about the Faraday's laws of electrolysis. So who explained the laws of electrolysis? So what is the present concept? Faraday's laws of electrolysis. Now tell me, who explained the laws of electrolysis? Definitely Faraday explained the laws of electrolysis. The main concept of Faraday's laws is it explains the deposition of the substance at the electrodes by the passage of current. So what is the importance of Faraday's laws of electrolysis? It explains the deposition of the substance at the electrodes by the passage of electric current. He explained in Faraday's first law and Faraday's second law. So coming to the Faraday's first law, the amount of the substance that is deposited or liberated or dissolved at any electrode is directly proportional to the quantity of electricity passed through the electrolyte. So Faraday's first law can be mathematically represented as the amount of the substance deposited is directly proportional to the quantity of electricity passed through the circuit. So always the quantity of current passed through the circuits will be measured in terms of coulombs, and that implies W is equal to EQ, and Q, the quantity of electricity, Q is equal to CT. CT means C is the current in amperes, T means it is time in seconds. So W is equal to ECT. So it is the mathematical expression for the Faraday's first law. Here E is known as electrochemical equivalence. Here the unit for electrochemical equivalence is E equal to W by CT. That means gram per coulomb, or it can also be expressed as gram per ampere inverse second inverse. You are mostly supposed to identify what is the unit for electrochemical equivalence, gram per coulomb or gram ampere inverse second inverse. So coming to the Faraday's second law, so whenever the same quantity of electricity is passed through different electrolytes connected in series, then the amount of the substance deposited or liberated is directly proportional to its chemical equivalence. Or in other words, it can be called as equivalent weight. So mathematically it can be expressed as the amount of the substance deposited is directly proportional to its chemical equivalence, that means equivalent weight. Here two or more electrolytes will be connected in series. Very good, Swati. That implies W by E is equal to constant. So mathematically the second law can be expressed as W1 by W2 is equal to E1 by E2. It is the mathematical expression for the Faraday's second law. So here we can also discuss about the formulas that are highly useful for doing problems. Okay, W1 by W2 is equal to E1 by E2 is Faraday's second law. W is equal to ECT is Faraday's first law. And similarly, we can derive an expression or between small e and capital E, that is capital E is equal to small e into F. And sometimes you are supposed to use the expression W is equal to ECT. In that you have to substitute the value of E. So small e is equal to capital E by F CT. So whenever the equivalent weight of the substance is given, not the chemical equivalence, then you have to use this expression. So otherwise, if you know only atomic weight, equivalent weight can be obtained by dividing atomic weight with valency. There you can use ACT by NF. N represents the valency, A represents the atomic weight. So by using these expressions, it is more convenient to get the answer for the given problems. So in particular, electrochemical equivalence, small e means it is the amount of the substance that is deposited at the electrode by the passage of 1 coulomb of electricity. And coming to the chemical equivalence, that is capital E, it is the amount of the substance that is deposited by the passage of 1 Faraday of electricity. Now, would you like to share what is the value of 1 Faraday? 1 Faraday is equal to what is the value of Faraday? Swati, will you share the answer? What is the value of Faraday? Very good. 96,500 coulombs. You try to do the problems based upon Faraday's first and second laws. Now it's the time to discuss in detail about the electrochemical cell. Now tell me, what is the importance of electrochemical cell? What is the importance of electrochemical cell or galvanic cell? What is the importance of electrochemical cell or galvanic cell? Meanwhile, I will construct a galvanic cell. Very good, Swati. It is a device that is used for the conversion of chemical energy into electrical energy. And in the case of galvanic cell, anode is made up of. You try to share the answer. In the case of galvanic cell, here Daniell cell is good example for galvanic cell. So in the case of Daniell cell or galvanic cell, the anode is made up of in a galvanic cell, anode is made up of which metal? Will you share the answer? This is the salt bridge. And especially the salt bridge is made up of KCl solution plus ammonium nitrate. First electrode will act as anode and the second electrode will act as cathode. So especially in the case of galvanic cell, a zinc rod will be dipped in zinc sulfate solution and the copper rod will be dipped in copper sulfate solution. So here in the case of galvanic cell, zinc rod will act as anode whereas copper rod will act as cathode, and these two electrodes are connected through voltmeter. The two electrolytic solutions, zinc sulfate and copper sulfate solutions, are connected through salt bridge. Generally, the salt bridge is made up of electrolytes such as potassium chloride or ammonium nitrate. So, the choice of potassium chloride is the mobility of potassium ions is exactly equal to the mobility of fluoride ions. So here this salt bridge is a porous material and that is made up of a non-electrolyte like agar or gelatin gel. So into the porous part, potassium chloride solution or ammonium nitrate solutions will be taken. So what is the importance of salt bridge? So it is mainly useful to maintain electrical neutrality at the electrodes. So here in the case of a galvanic cell, a zinc rod will be dipped in zinc sulfate solution, copper rod will be dipped in copper sulfate solution. Zinc rod will act as anode, copper rod will act as cathode. Both these electrodes are connected through voltmeter. Both the electrolytic solutions are connected through salt bridge. Whenever the connections are collected, so whenever the connections are completed, then what happens? A redox reaction takes place. Redox reaction means it involves both oxidation and reduction. So let us see what are the reactions that are taking place at the electrodes. So at anode, oxidation takes place and at the cathode, reduction takes place. So at the anode what happens? Oxidation takes place. So at the anode the zinc rod starts dissolving and results in the formation of Zn plus 2 ions with the loss of electrons. Coming to the reaction at the cathode, the copper ions from the electrolytic solution will start gaining electrons and gets deposited as the copper. So as the time proceeds, the thickness of the copper rod increases, whereas the thickness of the zinc rod decreases. Here always the flow of electrons takes place from the anode to cathode. So here we can calculate how much amount of the electrode potential, that means the EMF of the cell. We can calculate the EMF of the cell. So the EMF of the cell is equal to reduction potential of cathode minus reduction potential of anode. So the amount of current produced in galvanic cell can be calculated by using the formula EMF of cell is equal to reduction potential of cathode minus reduction potential of anode. So in the case of copper, here copper is acting as cathode and zinc is acting as anode, and the reduction potential of copper is 0.34 and that of zinc is minus 0.76, and hence EMF of the cell, especially galvanic cell, is equal to 1.1 volt. Sometimes you may be directly asked to identify what is the EMF of the galvanic cell. Then it is 1.1 volt. So this is all about the electrochemical cell. Now here we can compare electrolytic cell with that of a galvanic cell. So let us compare an electrolytic cell with that of a galvanic cell. So what is the importance of an electrolytic cell? Yes, very good, Swati. So what is the importance of an electrolytic cell? It is used for the conversion of electrical energy into chemical energy. And what about the galvanic cell? It is used for the conversion of chemical energy to electrical energy. Very good, Swati. So here always a battery is required as the source of electricity. Here electricity will be produced. So in the case of an electrolytic cell, battery will act as a source of electricity. In the case of galvanic cell, electricity will be produced. Here, in the case of an electrolytic cell, anode is a positive electrode and the cathode is the negative electrode. But coming to the galvanic cell, anode will be represented as the negative electrode, whereas cathode is represented as the positive electrode. This is the major difference. Here, in the case of a galvanic cell, a salt bridge is required. So, in the case of galvanic cell, salt bridge is required. Here, salt bridge is absent. Especially in the case of an electrolytic cell, always the flow of current takes place. Flow of current takes place from anode to cathode. Can you guess? In the case of galvanic cell, the flow of current takes place from Kumari, will you share? In the case of galvanic cell, the current will flow from Swati. In the case of a galvanic cell, the current will flow from Next we will discuss about the flow of electrons. That will be in the reverse direction. So current will flow from cathode to anode in the case of a galvanic cell. And coming to the flow of electrons, in the case of an electrolytic cell, always it takes place from cathode to anode. So it is always in reverse direction to the flow of current. And coming to the galvanic cell, here the flow of electrons takes place from anode to cathode. So this is all about the differences between electrolytic cell and galvanic cell. Let us discuss about the electrode potential. So what is meant by electrode potential? It is the ability of an electrode to lose or gain electrons. So electrode potential means it is the ability of an electrode to lose or gain electrons. Now tell me, what is meant by oxidation potential? Will you share what is meant by oxidation potential? I am waiting for your answer. What is meant by oxidation potential, Swati? Very good. So, loss of electrons is nothing but oxidation potential. So, the ability of an electrode to lose electrons is nothing but oxidation potential, and reduction potential means it is the tendency of an electrode to gain electrons. So, gain of electrons is nothing but reduction, and the potential is called as reduction potential. Very good. So now tell me, what do you mean by standard electrode potential? So standard electrode potential means it is the electrode potential of the pure metal when it is in contact with its electrolytic solution of 1 molar concentration at 25 degrees centigrade. But remember that it is impossible to measure single electrode potential. Why? A galvanic cell requires two electrodes. So, we require reference electrodes. So, in order to measure single electrode potential, we require reference electrodes. We are having two such reference electrodes. One is standard hydrogen electrode and the second one is standard calomel electrode. So what is the importance of reference electrodes? Reference electrodes are highly useful to measure single electrode potential of any metal. So we are having two such reference electrodes, standard hydrogen electrode and standard calomel electrode. So the potential of standard hydrogen electrode is 0.0 volts and that of calomel electrode is 0.2422 volts. So reference electrode means an electrode of standard potential with which we can compare the potentials of other electrodes. Very good, Swati. So the potential of standard hydrogen electrode is 0.0 volts. Next we will discuss about the electrochemical series. Now tell me, what do you mean by electrochemical series? This is the last concept, that is electrochemical series. Now tell me, what do you mean by electrochemical series? Electrochemical series is very important to predict the reactivity of any metal, even to predict the corrosion tendencies of the metals. So it is the arrangement of metals in the increasing order of their standard reduction potentials. So especially reduction potentials are considered as standard potentials. Now will you share what is the relation between reduction potential and oxidation potential? Now tell me, what is the relation between reduction potential and oxidation potential? Meanwhile, I will represent the electrochemical series. You try to share the relation between reduction potential and oxidation potential. What is the relation between reduction potential and oxidation potential? Very good, Swati. Reduction potential is equal to -1 into oxidation potential and oxidation potential is equal to -1 into reduction potential. So for example, if 0.34 volts is the reduction potential of copper, then its oxidation potential will be minus 0.3 volts. Clear? If the oxidation potential of copper, for example, if you consider zinc, the oxidation potential of zinc is 0.76, then its reduction potential will be minus 0.76 volts. Okay. So, what is meant by electrochemical series? It is the arrangement of metals in the increasing order of their standard reduction potentials. Once, as we move from top to bottom in the electrochemical series, the standard reduction potential values increases. That is very clear from the value of lithium, zinc, hydrogen and copper. The reduction potential value of lithium is minus 0.305 and that of zinc is minus 0.76. Hydrogen is 0.0 volts. Copper is 0.34 volts. So, the reduction potential values increases from top to bottom in the electrochemical series. So, the metal which is present at the top of the electrochemical series is lithium. So, always the metals which occupy top position are active and they will act as anode. At the same time, the metals which are present at the bottom of the series are noble and they act as cathode. So, lithium being top in the electrochemical series, it is having more tendency to undergo oxidation. So, fluorine is present at the bottom of electrochemical series and it is having greater tendency to undergo reduction. So, lithium is having more tendency to undergo oxidation and hence it will act as strong reducing agent. On the other hand, fluorine will act as strong oxidizing agent. So, coming to the metals which are present above the hydrogen, they have a great tendency to replace hydrogen from the acids or from the water. For example, if you add zinc metal to HCl solution, it liberates hydrogen gas. So the metals which are present above hydrogen are highly active and they are capable of liberating hydrogen gas from acids or from the water. And whenever if you carefully observe the replacement tendencies, always the metals which occupies top position can easily replace the metals which are occupying bottom positions in the electrochemical series. That means whenever if you like to store copper sulfate solution in the zinc container, then what happens? Zinc is highly active and it replaces copper from the copper sulfate solution and hence copper sulfate solution cannot be stored in a zinc container, but we can store zinc sulfate solution in a copper container. Here no chemical reaction takes place. We can also predict the corrosion tendencies. The metals which are present above the series are highly active. They will have more corrosion tendencies when compared with the metals which are present at the bottom of the series. We can also predict the spontaneity of the reaction. So, if the EMF of the cell is a positive quantity, the reaction is spontaneous. This is all about the electrochemical series and its significance. If you like the video, like and share. Thanks for participating.